Today we are going to talk about Aviary, which is the name of a clinical collaboration platform that we built at work. So first off, a little bit about us. My name is Carmen. I am a software developer at the University Health Network. I've been writing Clojure professionally for almost 5 years now, and I'm also the author of the Cryogen static site generator.
And my name is Dmitri, and I've been working with Clojure for close to a decade now. And I maintain a few open source libraries. I'm the author of Luminous. I published the WebDevelopment with Clojure book, which I'm authoring the third edition of with Scott Brown, who is also in the audience. We're hoping to get it done soon.
Yep. Okay, so what is the University Health Network? Well, we are a leading hospital and research organization here in Canada. We have 4 hospitals across Toronto, and we are also Canada's largest research hospital. In addition to that, we also have the Michener Institute of Education, where we teach the applied health sciences, and we also partner with the University of Toronto. So UHN kind of has 3 main focuses. There's the clinical side, there's research, and there's education. And our team provides solutions for the organization's clinical needs, but oftentimes the data that's collected in our applications will be used later on for research and analytics. With that said, let's take a look at the clinical workflow in the hospital. So typically, when you are admitted to the hospital, you will have a multidisciplinary team that's responsible for your treatment and care. Usually you'll have a clinician, a nurse or two, and a pharmacist, but depending on your case, you might also see several other professionals, such as a social worker and a surgeon. And now we want to provide you good care, so everyone on this team needs to be aware of their patient status. This means everyone needs to be able to see the data and the notes that were collected by other members of the team. However, current electronic medical record solutions don't really fit into this workflow because they facilitate this serial kind of workflow where users will enter data one at a time. And this kind of a workflow can cause delays in the hospital because oftentimes information will not be available when we need it, or it gets out of date very easily, and users end up having to wait on each other before they can finish their own work. So what we really need is a solution that will allow the users to collaborate in real time without stepping on each other's toes.
All right, so with that said, let's take a look at some common client-server architectures and where our solution fits within that. So like the most basic one is doing server-side rendering, where all your business logic lives on a server. You have a thin client that's strictly responsible for rendering HTML on screen. And the advantage of this solution from our perspective is that it makes it very easy to synchronize across multiple clients because all the states on the server, anytime something happens, it has to go through a server. That's fine. But the problem with that is there is no really good way to dynamically refresh the UI client side in the browser. And I mean, you can do stuff like, add some JavaScript, like with jQuery approach, right? Like where you try to add some dynamic behaviors. But in our case, the whole UI can change like with a single interaction from a user. And it's not really practical. So
to add on to that, it's also not great for coordinating clients in real time because it's a pull-only architecture where the client requests data from the server. There's no way for the server to push data to the client.
Right. So a more modern approach for building web applications and not static sites is to use single-page application model. And this model pretty much flips the server-side rendering on its head, where all your logic moves to the client, and the server is really just responsible for stuff like authentication and data governance. So this is great. Now we can get this rich behaviors client-side, but coordinating clients becomes really difficult because each client has its own state, and we need to have a common shared state across them. So that becomes a non-trivial problem. So we moved into kind of a hybrid approach where we still have a rich client that's implemented in Clojure script, and the client is strictly responsible for the view portion of the application. So it does the presentation, it collects user inputs, but anytime an action happens, we send a message to the server. The server manages the shared state and applies business logic to it, and it does this transactionally. So anytime any client does an action, that any data that's produced by that action is transactional, and we notify all the clients using the WebSocket. And now we can have as many clients as we like, talking to the same server, and everything's fine. And in terms of scaling, our use case is that, as Carmen mentioned, we have a circle of care, and the circle of care around each individual patient there is a maximum number of people. You might have like 10, 15 people working with each other. So we may have a lot of concurrent users, but we have very few users per each individual document. And by session pinning, we're able to basically scale out horizontally.
Okay.
So, everybody loves demos. Nothing can possibly go live. We already learned that. So, let's do this.
Okay. Hopefully I don't mess anything up. Okay. So let me open up a demo form that we've created. Hello? Oh no, already? Carmen, blah. Oh, there we go. Just need to refresh. Okay. Okay, so here we've got a basic form open on the right side of the screen. I've logged into the window on the top, and Dmitri is logged into the window on the bottom so that you can see what happens when we've got two users working on the form. Here we have this little handy-dandy button that tells you who are the current editors of the form. And then looking at the left side of the screen, we have the form definition that's used to render this form. It's simply an Eden file containing a map, so let's take a look at what keys we have in here. Of course, our form needs a title, so we start off with that. And then we have some metadata describing the form. And following that, we have the two core components of a form, the model and the view. The model describes the total set of fields in the document, and then we create views into the model that describe how this data should be represented in the UI. So now taking a closer look at the model, this is also a map, so we can refer to each field using a keyword like so. And the field itself is also a map, so we can describe the path, as well as any additional properties. So for example, I can add some validation to this field, and let's make it required. And you may notice that once I save this file, on the right side of the screen, we now have a red asterisk next to the height field indicating that it's required. And this happened without me having to refresh. For those of you that have done any web development with Clojure, at this point you might think this is Figwheel, but it's actually not. Like Dmitri mentioned earlier, our client and server communicate via WebSocket. So during our development workflow, we have a watcher listening to changes to the form, and then anytime a change happens, we validate the form, do a little bit of pre-processing, serialize it into a database, and then the server can push the updated form to the clients. Now, moving on to the views, once again, this is a map, so we can define multiple views per form if we have different user roles. Right now, we only have one, this one, and it's the default view. And then looking at the form definition itself, our goal was to keep this semantic. So the definition closely matches what you see rendered. So we have a section containing 3 input fields, height, weight, and BMI. And because we define our form in this declarative fashion, we can have different UI implementations from the same definition. So right now we're only targeting web, so we have a widget library that will parse this definition and produce web components. In the future, we might be targeting mobile, so we could write another implementation to produce React Native components. And then one additional thing that I'd like to point out is that we bind the widgets to the model by referencing the same keys in the model. And the reason why we use the keyword is that this allows us to decouple the views from the model so that we could reuse views later on. And additionally, the views will not be affected by any underlying changes to the model. Okay. So now that I've explained what makes a form, let's see it in action. So I'm going to enter the height field, and you can see on the bottom screen where Dmitri is logged in, the field is now locked and he can't interact with it. And we do this so that when I'm editing this field, no data corruption can occur. So now I'm going to enter my height, which is 160 centimeters, and I'm going to tab to the next field, and Dmitri can now see the updated data, and he can also edit the same field if he would like to now. So a couple of things just happened here. When I click into the field and the focus event fires, we send a message to the server asking for a lock for that field. If we are successful in acquiring that lock, which we were, then the server notifies the rest of the clients that the field is now locked by me and no one should be able to edit it. When I finish making my changes and move off of the field, the blur event fires and we send another message to the server containing the update. The server will then once again notify the clients of this change and unlock the field so that everyone else is able to interact with it. So let's finish filling out this form. My weight is 48 kilos, so I know my BMI is roughly 18. But of course, I shouldn't have to calculate this manually, so let's see how we can add some logic to do this automatically. And because I don't want to embarrass myself by making a ton of typos, I have this on a different branch. And there you go.
All right, and so here's our idea of business rules. And what basically we mean by business rules in the context of our application is any function that takes data from the state of the document as an input and produces an updated state in the document. So in this case, we'll collect the height and weight fields, do some calculation, and produce an updated BMI field. And hopefully you can read this if it's not too small. But basically, business rules are a vector of maps. And each map contains a few keys in it. And the ones we're interested in would be inputs, outputs, and the fan key. So the inputs declare what fields in the document this rule interacts with, that's dependent on. So whenever one of those fields changes, this rule will be triggered. The outputs declare what fields will be produced by this rule when it runs. And the function takes exactly 3 arguments. The first argument is a context, which might contain user information and some other metadata. The second argument is a vector of inputs, and the last argument is a vector of outputs. So in this case, height, weight, BMI. And we're going to produce a vector, which is going to match the output vector. And in this case, we're going to check if our height and weight are valid, and if they are, we're going to compute the BMI. If not, we're going to set it to nil. And with this approach, we can know what fields need to be locked, even when you have complex interactions with other fields. So for example, now if I click on a field here, you can see both fields are locked, because both of those fields are requested by the rule. So now if a user is in one field and another user wants to edit another field that's related to it, they can't. So now we'll take a look at what happens if we have cascading rules. So we're going to add another rule here. And in this case, maybe once we produce a BMI, we want to add a note. So the standard terminology is underweight, normal weight, overweight, and it relates to certain BMI values. So what we did now is we have a new path in the document called note. We add a new field here, which is just a label. And then this rule will depend on a BMI, which is the output of the previous rule, and produce a note field. And what we do is when we load the form from the database, we create a direct acyclic graph for all the past relationships up front. And then whenever a field is changed by the user, the server will check the graphs, find all the related fields, notify all the clients of the total change set that's going to be locked, do all the operations transactionally, and then produce an output and notify all the clients with the new values and unlock the fields. And the rules are in a vector, so if you have 2 rules that have the same inputs, they'll be resolved in their order, so it's explicit.
So of course, let's make sure this actually works, because we can tell you it works, but until you see it actually working. Okay, ta-da, and Dmitri is also normal weight. Great. So it's really useful to be able to trigger updates to the document when fields change, but it's also very useful to change what the UI looks like when fields change. So let's see how we can do that now. Demo 4. Okay. So once again, we have a new key in our form definition called UI rules, and these work very similarly to the business rules. Once again, we have the inputs, which define which fields are going to trigger this rule, but instead of outputs, we have targets instead, and the targets are going to be IDs of widgets. So here I have a single ID called BMI specified, but if I scroll up a little bit, you can see I have the ID BMI assigned to both the note field and the BMI field. And this is useful if you want to control groups of widgets together. And then looking at the function now, once again, we take the context, which I'm not using here. We take in the two input values, and we have the target. And then, like the business rules, we produce a vector with an arity that matches the size of the targets. But instead of returning a value here, we are going to return a state change. So here, we would like to hide the BMI and note fields when either height or weight have not been entered. So let's make sure it works. Great. And you'll see that the fields have disappeared for both myself and Dmitri. And once again, these rules are computed on the server, and then we send the state change to the clients, and the clients will apply the change to the UI. Okay. Views.
Oh yeah, so the other thing we mentioned before is that we are in a multidisciplinary environment. And in practice, different disciplines of the hospital will present data different ways. And they have different nomenclature in their respective professions. They might call things differently. They might want to use different widgets to present the data and so on. So far, we've just seen multiple users working on the same presentation of the data. Now we are going to add a second view, or we already have. And now we have a pharmacist view you see here. And you see that right now I'm logged in. No, I'm logged in as a default user, but let's say I change my role to a pharmacist. And when I get back into the forum, hopefully, here we are.
Yes,
now you see my view looks a little different. And one thing I'll note is that right now I'm only showing height and weight. And if you look at the view definition, there is no BMI here. But if I do change my weight and, let's say, enter it, you'll see that the other view for the other user has been updated with the values. And that's because the rules run against the data model, not against a specific view. So regardless of what you're showing in your particular view, all the rules are guaranteed to affect the whole model and produce data even if the user doesn't care about it.
Okay. So now that we've collected some data in our form, we probably want to produce some sort of a report so that we can send it somewhere. And as I mentioned earlier, these form definitions are declarative. So once again, we can reuse this form definition to produce an HTML report that closely matches the layout of the form itself. So if we take a look at the upper screen here, you'll see, yep, that matches pretty closely. And if we take a look at Dmitri's screen, he has this additional medications table since he's in the pharmacist view.
Oh yeah, so this is another thing to note. Like we mentioned about alternate implementations, you can actually see that in action right here, because each version of our widget has two modes. One is the form mode where we interact with the user, another one is report mode that presents it in the report version.
Right, so it uses this exact same definition to produce this. So yeah, we can get reports for free without having to do any additional work, but sometimes you might want something that looks a little bit nicer, like a synoptic report. So let's see how we can do that now. Okay, so now we have a new key called reports in our form definition, and again, this is a map so that we can have multiple reports per form. And the one that I have here is called Custom Pharmacist Report. If I scroll back down to the pharmacist view, you'll see I've specified that this should be used in place of that default one that we see. So in the reports, you can just use plain HTML, like this H4 here. But you can also pull in values from the model if you like that to be displayed. So here I'm displaying the BMI and the note, even though they are not present in my actual view. And finally, we also allow widgets to be reused from the form definition. So this is the exact same section with the medications that we see down here. Of course, having this duplication isn't great, so we can actually pull this out into what we call a fragment. So let's do that now. I'm going to cut this. It's going to disappear from my view. I'm going to add a new file. Fragments. Medication. And once again, this is an Eden file. And it's going to contain some metadata, which is the ID of the fragment, medication table, and it's going to have the body of the fragment. And now we can use this in our form definition, like so. Type fragment, ID, medication. And hopefully that should reappear. Yes, great. Now let's go replace the one down here. And we're back. So the way we inject these is by using a pre-walk. So you can actually have fragments inside of fragments, and they work anywhere in the form. So you can reuse parts of the view and the model, the rules, within the same form itself or across forms if you'd like to. And that's it for our demo.
All right. So you saw a few things. I'd kind of like to unpack that a little bit. And first thing I want to say is that really, in my mind, this architecture is really driven by Clojure as a language. And the reason being that Clojure has a really rich way to manipulate data right in the standard library. And because of that, you really don't need additional abstractions on top of data. Data is really the abstraction we use in Clojure. And because we have as expressions, it's very easy to serialize and manipulate code as if it was data. So for example, like all the forum serialization stuff you guys saw we get it for free. We didn't have to write any additional code for it. We don't have to like use complex frameworks or libraries. It just works. Like it was a few lines of code. And I think like the other part was that is because you have less abstractions and you're just working with data, your mental model becomes simpler. So I really think Clojure encouraged us down this way. And if I was using a different language, I probably would have come up with a much more complex solution than we did.
Mm-hmm. And we mentioned earlier that the forms can be serialized into a database, and this is actually really helpful for us in production because we have this platform running many, many forms, and anytime we want to update a form or add a new form, we don't want to take down the whole platform. So we just dump it into the database, the app reads it out, and we don't have to have any downtime.
All right, so let's go like through a few things we think are notable and might be useful for other people when you're building your applications or thinking about your architecture. So one of the things is having everything data-driven. And this is really inspired by our use of reframe on the client, except we kind of extended this model all the way to the server side. So the client has the view, it dispatches some events, server runs the business logic, and then notifies the views of the updated state. Another interesting part is the alternate implementations we mentioned. So as you saw, for example, when we have default widgets for the forum versus report widgets, React Native, so on. And I think the nice part about that is data becomes your DSL, right? Like when you interact with our forum definitions, when you build forums, there is no real hidden state. Everything is explicit. Everything is right there in front of you. And data is inherently inert. But like internally, it's backed by thousands upon thousands of lines of code, but the user doesn't have to be aware of them. And they don't have to know like if that code has special behaviors or doing something funky. They can just interact declaratively. And I think that's what you see in a lot of other languages, why people use frameworks. Because frameworks are configurable, right? Like you don't write code against the framework, you write a configuration file for the framework, and the framework does the magic. So I feel like using those data DSLs is the same idea, but you don't have to accumulate the cost of having a framework in your application. The other part is, of course, extensibility. When you may express everything in data, it becomes really, really easy to export parts of the data to different files or whatever. And this is really powerful if you think about it, because like what Carmen showed in the trivial example is really useful for us in practice. We have big data models, and we have data specifications we have to deal with. And it would be impractical for us to hand roll a data specification for every single form and maintain them in sync. This way, we find common elements, export them. Like, for example, if we have patient demographics, we can have a patient demographics model, patient demographics view, and then we can use them anytime we want in any form. And again, like the amount of work we had to do for this was minimal.
I'd also like to add on to that with this kind of append-only approach, we noticed that we typically don't have to change any existing code to accommodate new behaviors. You saw that when I was doing the demo, every time we demonstrated a new feature, I just had to add a new key onto the form definition. And then when we add that new key to the form definition, we write the implementation in code. So yeah, we rarely need to go back and refactor when we receive new requirements.
Right, so this kind of results in this additive development workflow, and it's guided by your data structure, because elements in the data structure are inherently independent of each other, so implementations have to be independent of each other. And what happens is we load a form, as Carmen mentioned, we'll box the form, we look for specific keys, inject the implementations for those keys at runtime, and then we aggregate the behaviors at the top layer of the application. So we almost never have to go back and refactor code to accommodate new requirements in the code. Yeah. The other part is, of course, reusable components. You want to talk?
Yeah, as you saw, I was able to pull out that widget that I was using in both the view and the reports into what we call a fragment. And like I mentioned, we do a pre-walk to inject them, so we can inject a fragment, and then if that fragment contains another fragment, then it gets walked, and we continue to inject. So by doing this approach, we allow for really granular reuse of parts of the form without really having to plan for it up front.
Yep. So the other big part, and I think this is really important, and Raf, if you saw his talk yesterday, kind of mentioned a similar thing, is that sometimes formalizing things makes it much easier to reason about them. So if you see on the far side, we have kind of like, yes. So this is like a typical way we often see application structure. Maybe not a specific way, right? There, you could have some quibbles about using paths and whatever, right? But the idea is that that's what you commonly see in applications. And what I would call that is ad hoc business logic. Because I get a requirement to make a component like, say, BMI. I'll come in, write a function, reference some things, and display a BMI. But now we have a problem. Because if you look at it closely, you'll see that BMI is never actually stored anywhere. And if I was a developer who was required to show the BMI, I might implement that and not consider that BMI might also be needed in the report that's got mailed to a family physician. So now you're going to have a missing field, and you might forget to test for it, and then you're going to have a bad patient outcome because somebody forgot to add a field. So by formalizing those things, in our case, you cannot put business logic in your view because there's no way to do that. If you want to add business logic, you have to go through the model, and you have to declare what fields you depend on and what fields you output. And now this can be analyzed programmatically, and we can infer all those behaviors from it. But also it acts as a specification. If I come back to a complex form 6 months from now or a year from now, I can just scroll down to business logic and see all the business logic and how it relates to itself. But if I was doing the ad hoc fashion, as you see on the other side, it becomes really difficult to do. And I'm sure we've all been there if you maintain the long-running application where you have to come back after a while and find some code and be like, okay, well, I'm going to change this, but I'm not sure how it relates to the rest of the code. Because maybe I didn't write it, maybe I wrote it a long time ago. Who knows?
Right. And we work for a hospital, so of course our apps run for like decades.
Quite often, yes.
Yes. Okay.
Another thing I'd like to talk about, and we didn't really touch on it during the demo, but I think it's a really important topic, is data governance. And I find there's two types of applications. There's applications where the data is only used within the application. And in those cases, you just have a single data model and you don't really care. But in a lot of cases, the data tends to have uses outside the application that produced it. And in our case, that's the default case because we interact with a lot of different medical systems. So we need to share data across the organization. And for medical data, in North America, there is a standard called HL7, and the latest revision of it is called FHIR. And it's a very complex standard, and it's difficult to implement. And what we ended up doing is we decided to separate the UI model from the data at rest model. So when we build a form, we build a model that closely matches the UI that the user sees. And this makes it really easy to work with it. Now, what happens in practice, in the bigger picture of the application, is when we open a document or create a document, we interface with other systems such as demographics, patient scheduling, allergies, medications. We pull all the data in, we normalize it into the form data model, let the user work with the data, and then when they submit the form, we export it back to wherever it needs to go. And having this separation is really powerful because now you can focus on building your UI and you're providing the user experience that the users need, and then worry about how you're going to export the data at a later time. In our case, we have main uses our clinical data repository. And it's a product called 8box, and it's built by a company called Health Samurai, who also happen to use Clojure, which will come in relevant in a minute. The other use for us is education and research, because often what happens is, because we're a research organization, data will get collected in a clinical context, but then people use it for research and analytics. And so Health Samurai actually built a really nice library for us called Ironhide. You can see the link in the bottom there. And Ironhide wraps Spectre internally, but provides this declarative data-driven API for us. And whenever we want our form to import or export model, we use this bidirectional mapping to decide how the data needs to be mapped. And we can do this on case-by-case basis as needed. So often what the workflow is, we talk to our users, find out their specific workflow, address the workflow, build a data model for that workflow. Then a few months later, somebody comes in and says, oh, I'd really like to get analytics across these forms for my research. So we'll go in and we'll figure out how to map the fields from each form to FHIR, create this mapping, and now we have data export. And we didn't have to plan for it up front. And the other big advantage of this is that it's resilient to changes in this at-rest model. So for example, FHIR isn't currently normative.
Even though it's being used.
Yes, even though it's being used in production by a lot of people. And the problem with it not being normative is sometimes it can have breaking changes. So if we try to, and we did try this before, and we had terrible results. We tried to use FHIR as our normative data model, and it was just impossible to keep up with. We couldn't get anything done. So instead, we took a step back and said, let's separate those two things. And that works way, way better.
So that is almost the end of our presentation. We hope you learned some things that you can apply to your own projects. But let's take a look at some key takeaways. First, we realize that you don't need to get fancy with your DSLs. You don't need to write macros. Just describe your API with data and then compile it at runtime, and you can change your implementation later on too without having to change your API when it's written in data. The next thing is that explicit behaviors are much easier to reason about than ad hoc business logic. As you saw by formalizing our rule definitions, we didn't have any hidden or implicit behaviors going on in our form. And finally, we really recommend separating your UI model from your at-rest model if the data that you collect has uses outside of your application. So that concludes our talk, and now we'll open it up for a Q&A.
Hello. Hello. Great talk. Really interesting. So I have a question about the business rule functions that you guys have. So what happened? Where do you store that? Because it seemed like that was part of the whole form, and that's going into like a column in the database. Where's the function going?
So literally goes in the forum.
Okay, so
And
you literally like quote it and then...
Yeah, so what happens is we serialize it to the database. When we load the form, we go through the business rules and we eval them. And when they eval, we contextualize them in the business rules namespace, so we have like a few more helpers inside if you need like additional functionality. The other thing we didn't really show in this demo is we also have support for having a functions key. And the functions can declare commonly used functions across business rules, and then they get injected in that context key you saw in the rule.
Right,
So
something like
Yes.
like this. Actually, I'll put it here. Functions.
yeah, so we can
BMI.
have something like a functions key, add the function, then pull the function out of the context. And as you saw with the fragments, right, we can just export all our common functions and reuse them.
Yeah. So yeah, then that's available in the context, and we can pull that out and reuse that instead of this one that's defined here.
Yeah, so caveat here is this only works for server side because you actually have to evaluate them.
Right, sure.
It should be like that, or something like that. Yep.
All right, I got one more question. All right, cool. So I saw that you're using the model namespace keyword for bringing in attributes.
Great.
So it wasn't clear to me when you know you're supposed to do that. Like, is that just something that it knows to look for the model key and then go find BMI?
Yeah, so that was actually a bit of an evolution. And going back, I think everything should be namespaced, but it is what it is. But basically, the reason we started using namespace keys, and this was actually Scott's idea. If you saw his talk yesterday, he expanded a bit more on it. But the idea is they're really easy to find when you walk the forum, and then you can dispatch a multi-method on your namespace key. So then you just see the namespace, aha, this is in the model, use the model thing, and it'll do the right thing with it. And this makes it really easy to make this like extensible behaviors. And like, for example, like the path, in my opinion, should be namespaced, because that way you could have different kinds of paths and you can contextualize them. And then when you read it, it becomes really easy to tell what sort of key it is and what functionality it has. So yeah, like retrospective is everything should have been namespaced, but.
Right, so just to clarify, the actual key portion of this keyword just references the keys that we have up there in the model, but we prepend it with the model namespace just so it's easier for us to parse.
Last question. Because nobody else is going.
Anyone else? No?
Okay, last question. How do you synchronize the state on the server? Is it an atom? Is it like a STM? How do you do it?
So internally, we actually use an atom of atoms, because what the model is, we have forums loaded, and for each forum, we might have multiple documents. So you have an atom containing all your forums, then each forum contains an atom with its documents, and document basically has an atom of users.
Yeah, I think it's 3 atoms.
And the idea is like the reason we need to be this granular is because we want to make sure that we're not blocking all the users, but we only want to block for a specific document.
Right.
And basically, yeah, that's all that happens, right? Like you get a notification, you look up your path, forum document user, do some fields, and magic happens.
Thanks.
I was just wondering on the locking part, do you have, or how do you deal with an issue perhaps of some kind of stale lock? You know, someone's editing a field and they walk into a Wi-Fi dead zone, and how does the app deal with that?
Right. Really, it's pretty much just timeout right now.
Okay.
So eventually your user will get kicked off the server and then the lock will get cleared.
I think the WebSocket connection drops, and then eventually the server will clean them up.
Yeah.
Yeah.
Quickly, your system becomes aware of novelty on the back end by the API updating the atoms?
Could you clarify?
Well, are you...
Oh, I see what you mean. Yes, like when it knows when to refresh dirty state.
Yeah.
So this is actually done explicitly by the input-output keys. Because what happens is when a user makes a change, when we send a message to the server, we send path plus value pair. And the path indicates, you know, what path the user changed. Then we check the graph of rules and find all the paths for those, and that's how we know the total change set.
There was another one? Yeah.
A race condition.
Hey, great talk.
Thanks.
I was wondering what was the design or how did you get to this design? If it was your first, or I don't know, if you tried a different, more traditional approach first and based on some constraints or
so there's a bit of a history behind that. Roughly 5 years ago, we did this application for a small clinic in the hospital, and they had only roughly 30 users, and we didn't have this model back then, so we had to lock the entire document when someone wanted to work on it. And they would log into the application, start doing their work, and then they were doing it on iPads. So they would put the iPad down, walk away, and forget about it. Then someone else would want to work on the assessment for the patient, and they would have to call us and say, hey, can you unlock this for us? So this kept happening over and over again, and it was only a clinic of 30 people. A couple years after that project finished, we were asked to do another project, except this time it would be used across all 4 hospitals. So at that point, we kind of took a step back and said, okay, this isn't feasible anymore. We can't be answering phone calls for the entire hospital. What can we do? And then,
Yeah, so then we kind of went through a few iterations, and part of this approach actually comes from our original app that we wrote for the clinic. And the clinic was a bariatric clinic, and it's basically a surgery where they remove part of the stomach. It's a risky procedure, so they have a very complex assessment to make sure it's safe to do for a particular patient. And we had a requirement actually to do it on iOS. And the procedure, it's called the Boston tool, which is basically the spec for it, for the report. And it's like over 100 pages of questions. So we started building the app, we quickly realized, it's really impossible to just do it screen by screen on iOS or something using the designer tool. That'd be completely unmaintainable. So we actually came up with a sort of React style model back at that time, where we used JavaScript core as our business engine, and then we implemented all our widgets as native iOS components. And then basically anytime component would do something, we go to the engine, and then we send notifications back. So we kept that aspect of a model in the new system, but we also now figured out a way, if you move the rule engine back to the server, now you only have to actually log the whole document. And that's how we landed on the solution.
Nice. Thank you. Very interesting.
Thank you.
I think there's, one more, right?
Okay, you can take it.
All right, thanks. I was just wondering, so applying this to other use cases, there might be instances where certain fields are only edited or visible by certain roles.
Right.
Do you control that entirely in the view, or do you have anything in the model that could kind of enforce that?
Nope, the model is available to all of the views, and the views just specify what fields should actually
So
be presented.
that information is captured, sort of distributed across the views, and it's not sort of centralized anywhere?
No, it's, no, you're right. Whatever happens in a particular view is meant to be, for a specific user group or a specific type of user.
Right.
But what the model does do is it provides a comprehensive set of relationships across the fields. So you saw the required field, but we can also do things like, this field is required when another field has a particular value. And you can do this cascades and logic of your requirements. And actually, we haven't really shown that.
I didn't show the rest of the options that we can put into the model.
But I think if you log one user out and do submit, and you don't have the height.
Oh, yes, if I put that back
it's not
here.
required. Make it required. So you can see
Come on, refresh.
Or you won't see.
Did it time out? It might have timed out. No?
Oh, maybe the form isn't compiling because you added the functions.
Oh, yes, that's why. You're right.
In a console, we'll get a nice spec error, but not in the browser yet.
I think we did get a gigantic spec error. Yes.
Yes, if you scroll up, actually, you should be able to see. It should tell us what key it didn't like. We need to elude the stack trace.
No, I had mismatched map, but yes. Otherwise, there would be a spec error. But yeah, so the field is required now.
And if you submit.
If I try to submit, then.
Yeah, so we can do this total validation completely automatically.
But that's sort of validating the entire.
Well, it's a bit more clever than that because we don't the model could be huge, right? It could be thousands of fields. So we don't want to send all of that to the client. So what we actually do is we prune the model based on what the view is selecting from it, plus what the rules associated with the view select from it. So each client will get a subset of the model, but we make sure that any overlaps between them are handled correctly.
You're not even transferring like data that client shouldn't have over the water.
Exactly.
Right.
And like the example with the BMI was, right, like where one user only works with the height and weight, but the other user cares about the BMI. So even though I don't know about BMI and never actually see it, it still gets calculated for the other user. No problem.
Okay, that's it.